So here we're going to start out the Exam 3 review looking at the graph of a function and determining a few things about it. Starting off with the local maximum and minimum, the absolute minimum and maximum, the intervals of increase and decrease, intervals of concavity, and inflection points. So let's start off with the first one, looking for the local maximum and minima. And so we see a couple of these kind of points here for the local minima. It's the points where the graph goes down to a bottom point and then turns around and comes back up. So for local minima here, we have 2 points, negative 9, 4 and 1, negative 2. So those are those 2 coordinates there. And then we see 2 local maximum points where the graph goes up to that point and then turns and goes down. So these would be at the points negative 3, 4 and 4, 1. Okay, and then the question about absolute maximum and minimum take the form of asking what is the very lowest that the graph goes down to and what's the very highest that the function goes up to. So in this case we do have a very low point below everything else down here. That'll be the absolute minimum as well as our local minimum. So that would the absolute minimum would occur at x equals negative 9 and the value is negative 4. Now do we see an absolute maximum? In this case we don't, because this graph continues to go up and so it's going to continue to increase without ever stopping. So it has no absolute maximum in this case. Now the next thing we'll take a look at are the intervals of increasing and decreasing. So following along this graph here, we see it decreasing on this side, and it decreases all the way to negative 9 right there. So between negative 15 and negative 9 it's decreasing. So we'll write down that down here, negative 15, negative 9 is the first interval. And then we also see it decreasing on this side. That's going to be between negative 3 all the way to here at 1. So another interval would be negative 3, 1. And then it starts going down over here as well. So there's where it's also decreasing, and that starts at 4 and goes off as the graph continues toward infinity. So another interval of decrease is 4, infinity. Now the intervals of increase be increasing on all the other parts of the graph. So we have one interval of increase as negative 9 to negative 3, and another one between 1 and 4. And that tells us all that we need to know about where is it increasing and where is it decreasing. Now let's go ahead and clear this out and then talk about the concavity information. So to recall, when we talk about concave up, the graph has a shape like a kind of cupped upward, like so, and concave down has a shape, it kind of curves downward, kind of cups downward, like so. So let's look at this graph and figure out where is it concave up and where is it concave down. Well, I'm going to kind of indicate on this side of things it's concave up, and then it's concave down, concave up, concave down, and then finally it kind of goes concave up again here on the other side. So these points where it changes concavity from up to down or down to up, these are what we call the inflection points. So we have different intervals then we'll write down here for concave up and down. Let's identify these points that we have here. -6, -1, -2, -1, 2, -1, and 7, -1. These are all the inflection points. So we'll say here's this thing is concave up between -15 and -6. Also between -2 and +2, it's concave up. And then also from this inflection point at 7 off to infinity as well, 7, infinity. So 3 sections where it's concave up: -15, -6, -2 to 2, and -7 or +7 to infinity. So what we can then see then is between all the other areas where it's concave down. So we can say it's concave down on the interval between -6 and -2, and also the interval between 2 and 7. And then the last two things we'll take a look at is the limit as x approaches 15 from the right of f of x, and the limit as x approaches infinity of f of x. So if we look at the graph as x approaches 15 from the right, as we come in from this side, as we've done before, we'll look at the direction the graph travels. It continues to travel up, getting closer and closer to this vertical line. So that would be infinity would be that limit. And we can also say that x equals -15 is a vertical asymptote as a result. Looking at what happens as x heads off itself to infinity, we look at the behavior of the graph. It continues to go down here, gets kind of flattened off as it approaches this horizontal line. So we say the limit as x approaches infinity of f of x is -3. And we can also say that y equals -3 is a horizontal asymptote as a result.